Hello everyone, welcome back to Brighter Brainz. So before going into the video, just please like, subscribe and share this video. Okay. So today in the previous video we have discussed about the introduction of the pair of linear equations. Now today we are going to discuss the first topic, that is graphical method of finding solution of a pair of linear equation. Pair of linear equations. Okay. So first, how do you find the solution using a graph? Okay. So a pair of linear equations is nothing but we will be having some like a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These are the two linear equations. These are the pair of linear equations. So from this we are going to draw the graph for the first line and the second line. Okay. So first we are going to draw the graph for this first line. In polynomials you will be drawing the graphs for the particular line, particular equation. So in that way also you need to draw two graphs, two straight, you will be getting two straight lines. Okay, because we are having two equations, so we will be getting two straight lines. So when you will be like, if it is like this, I am saying just an example. So if this equation is, if the graph of this equation is like this, and if the graph of the equation is in this way, okay, so the intersection point of these two straight lines will be the solution of the two pair of linear equations. Okay, so this is the graph of second line and this is the graph of first line. Okay, but in the graphical method, when they are giving some sort of questions, okay, before going to draw the graph, first you need to know which type of lines is it. Is it a parallel lines, or else is it an intersecting line, or else it is a coincident lines. I already explained what is parallel lines, intersecting and coincident. Okay, so parallel lines you will be not getting any solution. Intersecting lines you will be getting only one point. Coincident lines, coincident line is nothing but the line, the another line will be overlapping on the same line, so you will be getting some infinitely many solutions. Okay, so in that way, first we need to, first step, what is the first step? First you need to know the type of, or else nature of the line. Is it a parallel line, or else intersecting line, or coincident line? Okay, so let us take an example first. Let us take example from your exercise itself. So exercise 1, let me rub this. Okay, so exercise 1, let us take an example of 5x minus 3y is equal to 11 and minus 10x plus 6y is equal to minus 22. These are the two linear equations. It is a pair of linear equation. First we need to know what type of linear equations these are. Okay, so first a1 by a2, what is a1 by a2 here? 5 by minus 10, is it? Next, so if we simplify this, we will be getting minus 1 by 2. Next, b1 by b2, minus 3 by 6, this is 1 by 2, minus 1 by 2. And next, c1 by c2, 11 by 20, minus 22, that is minus 1 by 2 again. So here a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So which type of a relationship is it? If all are equal, which what is the nature of the line? These two lines, these are coincident lines. These are coincident lines. So coincident lines having infinitely many solutions. They are having infinite solutions. Okay, infinitely many solutions. 11 is in RHS side and minus 22 is also in RHS side. So if both are RHS side, we can take in this way. If one is LHS and another one is RHS, you need to go to ER consideration. Okay, done. So these are coincident lines. So we are going to get many solutions, So let us draw the graph for this. Let us draw graph for this. So first, for drawing the graph, as we learnt in polynomials also, so the same way you need to get the y value in for the both of the equations. Okay, first let us consider first equation, that is 5x minus 3y is equal to 11. Done. So transpose, here y term is negative, it should be positive because we need the y term, y value, so it should be positive. Let us transpose this to the RHS and 11 to this LHS. So it becomes 3y. If we transpose that to that side, minus 3y will be turning it as plus 3y equal to, already 5x is here and plus 11 will be this side, minus 11. And what is the y value here? 5x minus 11 by 3. It is multiplying here. So after transposing, it will be divided. Done. So first equation we got. This is the first equation. First, let us find the solutions for the first equation. So frame a table in this way. What is y? Y is equal to 5x minus 11 by 3. Next, x comma y. This is the ordered pair. Okay. So in this way, you need to frame the table. Okay. Done. So first of all, let us take 0 first. Let us take 0 and then 1 and then 2, 3, 4, 5, 6. 5 to 6 values are enough. Okay. So first, if we substitute 0 in place of x, what will be the value of y? Y is equal to 5 into 0 minus 11 by 3. That is 0 minus 11 by 3, which is equal to minus 11 by 3. Here we are getting the fractional value. So to avoid this fractional value, we will be doing we'll do one thing. We'll be taking the value of this 3 divided by 11. 3 3s are 9. So if we subtract 2 again, place the point and 0. This is 18 6 times. So approximately we will be taking it as 3.6. That is 0 comma 3.6. Done. Next, if we place y in the place of if we place 1 in place of x, so y is equal to 5 into 1 minus 11 by 3. So which is equal to 5 minus 11 by 3, that is minus 6 by 3, which is equal to minus 2. So it is 1 comma minus 2. Done. Next, if we substitute 2 in place of x, so 5 into 2 minus 11 by 3, which is equal to 10 minus 11 by 3, which is equal to minus 1 by 3. Let us know the value of 1 by 3. Okay. So 1 should be divided with 3. Let us place 0 point and then we will be placing 3 times. So approximately we will be taking it as 2 comma 0.3. Okay. Next, place 3 in place of x. Y is equal to 5 into 3 minus 11 by 3, which is equal to 15 minus 11 by 3, which is equal to 14 by 3. Is it? Now find the value of 14 by 3. 3 4s are 12 and 2 will be left over. Again placing the point 0 6 times. That is 3 comma 4.6. It is equal to 4.6. Done. Next, y is equal to 5 into 4 minus 11 by 3. 5 4s is 20. 20 minus 11 will be 9. 9 divided by 3, 3. Okay. So it is 4 comma 3. Next, if we place 5, y is equal to 5 into 5 minus 11 by 3. 25 minus 11 is 14. 14, huh? Is it 14? 25 minus 11. 14. 14 divided by 3. We already know the value. 14 divided by 3, that is 4.6 again. So 3 comma, 5 comma 4.6. Next, y is equal to 5 into 6 minus 11 by 3. 5 6 are 30. 30 minus 11. Sorry. Here 20. 20 minus 11 will be 9. Okay, correct only. 5 6 are 30. 30 minus 11. 19. 19 by 3. So it is approximately equal to 6.3. Is it? So 6 comma 6.3. Okay. But here we are getting it is 4 by 3, right? 15 minus 11, 4 by 3. So what is the value of 4 by 3? 3 ones are 3. Again point. This is 10 will be, and it is 3 and 9 times. Okay. So the value of this is 1.3. 3 comma 1.3. Okay. So the we got these solutions. Let us write it as aside. Okay. Let us write aside. So first 0 comma 3.6, and second solution is 1 comma minus 2, third solution 2 comma 0.3, and fourth solution 3 comma 1.3, fifth 4 comma 3, next 5 comma 4.6, and 6 comma 6.3. So in this way we got all the 6 solutions for the equation 1. And next let us find the values for equation 2. Okay. So for the equation 2, so for the equation 2, what is the equation 2? Minus 10x plus 6y is equal to minus 22. Here y is positive, so you don't need to transpose anywhere. Transpose this x term towards that side. So 6y is equal to 10x minus 10x will be plus 10x minus 22. Y is equal to 10x minus 22 by 6. Okay. So again, let us take what is y value? 10x minus 22 by 6. Okay. Substitute 0 in place of that. So it will be minus 22 divided by 6. So divide 22 with the 6. 18 is it? 6 3s are 18. 4 will be left over. Again placing the point and 6 times. So it is minus 3.6. That is 0 comma minus 3.6. Okay. Next placing 1. So 10 into 1. 10 minus 22 will be minus 12 by 6, which is equal to minus 2. That is 1 comma minus 2. Done. Next placing 2. 10 into 2 will be 20. 20 minus 22 minus 2 by 3. Is it? Minus 2 by 6. That is minus 1 by 3. So the value of minus 1 by 3. Previously we found the value of 1 by 3. That is placing 0 point and again placing, it is 0.3 approximately. Okay. So this is minus 0.3. So 2 comma minus 0.3. Okay. Next, if we place 3, so 10 into 3 will be 30. 30 minus 22 is 8. 8 by 6. Again 8 should be divided with 6. 6 ones are 6. 2 will be left over. Again placing point, and it is 6 3s are 18. That is approximately 1.3. So that is 30 minus 22 will be 8 by 6, which is equal to 1.3. That is 3 comma 1.3. Okay. Next, for place the 4 in place of x. 10 into 4 will be 40. 40 minus 22 will be 18. Is it? 18 by 6, which is equal to 3. So that is 4 comma 3. Next, 5. Place 5. Rashmita, please say. Place 5 in place of x. 10 into 5 will be 50. 50 minus 22. 50 minus 22. 28. So it is 28 divided by 6. So find the value of 28 by 6. 28 by 6 is 6 fours are 24, and again 4 will be left over. 6 times 36. Okay, 4.6, which is equal to 4.6. That is 5 comma 4.6. Next, substitute 6 in place of x. 60 minus 22. 60 minus 22 will be 60 minus 22. It is 38, right? 38. 38 by 6. This is 6.3 around. Is it? So 6 comma 6.3. So we got the values for the second equation also. We got the solutions for second equation. Now let us write these solutions aside. First solution is 0 comma minus 3.6, 1 comma minus 2, 2 comma minus 0.3, and next 3 comma 1.3, 4 comma 3, 5 comma 4.6, and then 6 comma 6.3. Is it? So now I'm just rubbing this table. Let me draw the graph. Now we need to plot all these solutions. For this is equation 1, this is equation 2. These are the solutions for equation 2, and these are the solutions for equation 1. So now let us plot the points. So first, draw the y-axis and the x-axis. Okay, this is the origin, that is 0. Let us place 1 here, 2, 3. Okay, place will not be sufficient. So 1, 2, 3, 4, 5, 6 and 7. Here let us take minus 1, minus 2, minus 3. Negative values we didn't took on the x. Here the x coordinate we didn't took any negative values, so we don't need to plot all the values. Okay, so next on the y-axis, 1, 2, 3, 4, 5 and 6. That's enough, and more than 6 is also there, right? 7. Next, minus 1, minus 2, minus 3, minus 4. Let us write these numbers in left side. Minus 1, minus 2, minus 3, minus 4, minus 5, and this is minus 6. That's enough. Now let us plot the first equation solutions. 0 comma 3.6. 0 is here and 3.6 will be on the y-axis. 3.6 around here. Is it? Around here. Next, 1 comma minus 2. 1 comma minus 2 will be here. It is, I think we made some mistake, I guess.
No, it's minus 3.6.
It is minus 3.6, and this one also minus 0.3. Minus 0.3. Okay, so first let us remove this point. So first of all, 0 comma 3 minus 3.6. 0 comma minus 3.6 will be here. Is it? Next, 1 comma minus 2. 1 is here. Where is minus 2? Here. exactly it is here. Okay, 1 comma minus 2, and next point 2 comma minus 0.3. 0.3 will be around here. 0.3 will be around here. Okay, next 3 comma 1.3. 3 comma 1.3. Okay, next 4 comma 3. 4 comma 3, it is here. You don't need to draw this, but I'm for without using scale I'm just doing, right, so that's why I'm drawing this dotted lines. Next 5 comma 4.6. 5 comma 5 is here. 4.6 will be around here. 5 comma 4.6. Next 6 comma 6.3. 6 comma 6.3 will be here. Okay, 6 comma 6.3. So in this way we got the equation. So let us draw the line. So from here you need to use scale because these are the straight lines, these are not the curves. So you need to use scale. Okay, you should not draw freehand. Okay, so it will be in this way, connecting all the points. Here is one of the point, and next let us plot the values for second equation. Say the 0.0 comma minus 3.6, it is here again, is it? It is here again. Next 1 comma minus 2, second equation, 1 comma minus 2, it is here again. 2 comma minus 0.6, 0.3, it is here again. 3 comma 1.3, 3 comma 1.3, it is here again. Next 4 comma 3, next 5 comma 4.6, and then 6 comma 6.3. Here two equations are lying on the same points, is it? So in this way, here in this line there are two equations, equation 1 and equation 2. 1 and 2 are lying on the same points and going in the same path. Okay, so these lines are called as coincident lines. So here we are going to get infinitely many solutions, but for both of the lines we are going to get the same solutions. So you can observe here. So from bottom you can observe 6 comma 6.3, and here also 6 comma 6. 5 comma 4.6, 5 comma 4 comma 3, 4 comma 3. So we are having similar solutions for both the equations. So such type of lines is called as coincident lines. Okay, such type of pair of linear equations called as coincident lines. Okay, done. Have you got an idea how to draw the lines? Okay.